started. So we were talking about options pricing, derivatives pricing in general. We looked at two ways of doing it. One is under very specific assumptions, you can derive a closed form solution, which we said was the Black-Scholes model. And then we looked at the binomial model of numerically pricing that option. So I've now set the second assignment you have to do. It's up on the hand-in page, so you can find this. And there are a couple of things I need to tell you about this, about what we are going to do in that. Yeah. So one of the things is when we derive the Black-Scholes model, I said that under some specific assumptions about setting up a portfolio which is hedged in a particular way, that is, I hold a certain amount of stock based on what the option price might vary, the delta. I can cancel out the stochastic part, or cancel out the uncertainty. And if I did that, I end up with a deterministic differential equation like this. And we just blindly said that some clever guys, namely Black-Scholes, solved that equation with these boundary conditions, and they derived this expression. Okay? So we can't just accept this as it is. So one of the tasks in the next assignment is for you to do what they did, but in a much easier way. The easier way is if some clever guy gives you a differential equation and says this is the solution, yeah, then you don't have to go through the same process of those guys to derive it yourself. You have the solution. You can convince yourself this solution is actually correct by substituting it back. You with me? Yeah. So that's what one of those tasks in the assignment is going to be. Yeah. So you will have the solution, and the task will take you through various steps in which you will compute these different derivatives of that solution, substitute it back into that, and convince yourself this is actually true. Okay, so that's one of the tasks. The other task is given a solution like this, where the call option price has a formula, what are the things that are needed to calculate the call option price? Yeah. The things that are needed would be the strike price of the option, its time to maturity, the risk-free interest rate you look up from the bank, and this term volatility sigma. Yeah. So what one does in practice is to look at, so we said that these stock prices under this geometric Brownian motion assumption will have a log normal distribution. So the log of those stock prices will have a normal distribution, and this sigma is the variance of that log normal distribution. Yeah. So what we can then do is to estimate this from a certain amount of data. Okay. So if we take a small window of data and estimate what the volatility is, then you can apply that and price the option. Along comes all the standard problems that you have in estimating something from data. You would want, for accurate estimations, long windows of data. And that's obvious. The more data, the more reliable the estimate is. But in time series data, where things are changing with time, if you take too long a window, you will smooth out any short-term variation. Yeah, so this is a compromise you can't escape from. Yeah, it's quite natural. So at that point, people have to tweak things based on some high-level knowledge you might have. You might think there's no reason to take that long data because you know that something's changed, and it becomes a practitioner's way of doing things. Okay, so you can appreciate that sort of thing in doing this practical. So that's the second point. The third point I want to make is that if you were to estimate this volatility from data, if you were to look up the interest rate from what the bank is giving you and plug it into the formula and price an option, what we are comfortable with is that we have started with assumptions of no systematic arbitrage opportunities. Yeah. But then these options are then traded in secondary markets. Yeah. You and I might enter into a contract and buy this option, and I have this contract from the bank which will enable me to buy the stock at a certain price at a certain time. But I might not want to wait all 6 months. Comes along another greedy guy, I might sell it to this guy. Yeah? So these things get traded. So it then turns out that the price that you would calculate from this formula, of which this volatility, for example, was an estimate anyway, yeah, may not be the real price at which this option is getting traded, because things might have changed over time. Okay? So one of the things that's often done in the real world when people trade these things is to ask the question, can I work out what the implied volatility is? What that term means is that you observe that the underlying stock has a particular trend. You observe that the options drawn on it are being traded at a particular price. Yeah. What do those market conditions imply about the way the market is actually moving? Yeah. So that obviously would be different from the assumption that you can make based on estimating something from historic data. Okay? So that is also something we can, so how would one do this? One would take this set of equations, plug in the actual observed option price, plug in everything else, and ask what value sigma should have in order to make these two match. So that's an implied volatility. Okay? So we can calculate that also in this lab work. And I have got you some data. So let's look at if I'm missing anything here. So if you go into handed page, you will see the assignment sheet. Okay. The algebraic part is looking more complex than it should be, because instead of saying just prove that Black-Scholes solution is correct, I've taken you through various steps. Derive this, substitute this, and confirm it's true. Yeah, so hence there's a lot more algebra than there should be. The data that you have, well, the sheet tells you where to find it from. And if you go into that, into the directory where that is, you will find 10 files. And the sheet describes what the file name is. The file name contains information about whether it's a call option or a put option, and what the strike price of this is. Okay? And that data should look like this. Okay, so this is a good picture stuff. So this data corresponds to sometime in '94 when I grabbed this data, and because I've used it in other publications, I thought I'll give this to you. The underlying asset is the FTSE index. The index was doing this, and there are 5 call options and 5 put options at different strike prices whose prices have been followed over that year. Yeah. Some things you can observe which may be intuitive to you immediately. So I've plotted in red the call option prices, and in blue the put option prices. Yeah. It may well be intuitive immediately that at the time when this underlying asset has been going down and down, yeah, the call option prices would have also gone down. Because the call option gives you the right to buy. Yeah? And if that thing is losing its value, then holding on to a paper with the right to buy is not a good idea. Yeah? So its value will go down. And of course the reverse is true, the put option price will be going up. Okay? There are a couple of other things you can see also that very close to the maturity. The actual maturity date is 1 day after this data. Okay? Very close to maturity. The actual value of the put option, you can see, would be the payoff. That will also be very clear. So this one, for example, you will find is, I think, 3325, and the value of that has a strike price of 3325. So 325 is the profit you will make if the underlying option has a value of 3,000. Yeah, so you can see some of those things in the data becoming immediately obvious. Okay? So I think so we will do this one. So we will calculate implied volatilities. In calculating implied volatilities, there is something that's there are some trends which people observe to be systematic. So I have listed them, I put them in those questions and said, do you see evidence of that in this data? Yeah. You may not always see this. People think that the option implied volatility at high strike prices and at very low strike prices with respect to the, at high and low strike prices with respect to the true price would be higher than in the middle. Yeah, so people see a trend this way and they call this the volatility smile. Yeah, so I have hinted at this. You can go and have a look at it in the literature. Yeah. And then we'll also do the binomial option pricing with this in the work. So what I would like to do is to make sure that everyone gets started. At the very least, make sure that you have just scanned through the black sheet that you have to do, the assignment sheet, and make sure you have grabbed the data and plotted this today. Yeah, so that you know that you have got to start. Yeah. I think I have set a deadline which is, well, you are going to say it's not very generous, 18th of March. I think the term finishes 2 days after that, on the 20th of March. So I think that's a reasonable deadline. If that day is particularly bad, you have 3 other coursework deadlines. Do you? Do you want to make it the 17th? Any votes? 19th, 20th? Better? Yeah? Okay, I'll shift it to 20. I'll do a 25 this, but then as you know later.
So, the deadline will go to 20.
Yeah, 20.
Yes, cool.
So we have another 3 days.
Yeah. And before that, we have intelligent agents.
Intelligent agent is
16 or 17?
17, yeah, 17. Yeah.
But I look into it. It's
5 questions.
it's only it's about non-cooperative game.
Yeah, no call.
Yeah, because it is about cooperative game. I cannot do that.
Why?
Because I don't understand. I have to review again.
Okay.
If the assignment is about cooperative, I wouldn't do that because I don't understand it. Because there's a lot of progress. No.
Oh, by the way, Chen, when is the next meeting with Seb? Do you know about? Yeah, the next one. When? Okay, got it. Yeah. Oh, by the way, how is your lecture review going? Yeah, lecture review. We should do that before the. By the way, did you scroll all the paper you need to read?
6 to 10?
6 to 10, 5 to 10. Is that possible? Next 3 weeks, around 3 weeks, we have to prepare the report and read 5 to 10 paper.
But I think in my way, I think you don't understand all of it. Just find the keyword, just find some point which algorithm that they use with data, which.
But you need critical thinking. You have to, understand a little bit. Okay.